To write equivalent fractions, you have two options. You may use multiplication or division. For 4/6, if I want to use division to write an equivalent fraction, I have to think of what can go into both 4 and 6 evenly. Since 2 can go into both 4 and 6 evenly, I would divide the numerator and denominator both by 2, and I would get 2/3, which is an equivalent fraction to 4/6. I can also use multiplication. When I use multiplication to find an equivalent fraction, I may multiply the numerator and denominator by any number as long as it is the same number. If I choose to multiply them both by 2, and I get 8/12. This is the second equivalent fraction to 4/6. For problems like numbers 5 and 6, where we're searching for a, had an interruption there. To find the missing numbers in fractions like numbers 5 and 6, we have to think of whether multiplication or division was used to get the numerator here in number 5. To get from 2 to 10, multiplication was used. So 2 times 5 is 10, 5 times 5 is 25. In number 6, 7 goes down to a 1, so division was used. 7 divided by 7 gives us 1, so we have to divide 21 by 7 to get the missing denominator 3. For numbers 27 and 30, we need to write the fractions in simplest form. So we need to ask ourselves what can go into both 10 and 15 evenly. Since 5 can go into both 10 and 15 evenly, we'll divide the numerator and denominator both by 5, and our answer is 2/3. And then we ask, can anything go into both 2 and 3 evenly? And since the only thing that can go into 2 and 3 is 1, we know it is in simplest form. For number 30, we ask ourselves what can go into both 12 and 16 evenly. We actually have more than one option. If we choose 4, which is the greatest common factor for 12 and 16, and we divide by 4, we get 3/4, which is the simplest form answer. If you choose to divide 12 and 16 by 2, which is another option, that's fine. So when you reduce the first time, you get 6/8, and then when you ask yourself, can anything go into both 6 and 8 evenly? Yes, 2 can. So you would have to divide them again by 2, and when you reduce 6/8 down to 3/4, you do get the final reduced answer. So it doesn't matter if it takes you more than one step to get the simplest form answer. Just make sure you keep dividing and reducing until you cannot reduce anymore. In lesson 6, we're comparing and ordering fractions. If it's a problem like number 1, where the fractions have the same denominator, all you have to do is compare numerators. 3/5 is greater than 2/5 because 3 is greater than 2. But when you have a problem like number 10, then you need to find common denominators before you compare the two fractions. So you need to ask yourself, you're looking at 4 and 20 as your denominators. Can 4 go into 20? Yes, so 20 is your least common denominator. 4 goes into 20 5 times. 5 times 3 is 15. Here the denominator stayed the same, so that means the numerator stays the same. Since these like fractions are equal, that means 3/4 and 15/20 are equal to each other. For a problem like number 20, where we're putting the fractions in order, we once again have to find common denominators and make like fractions so we can put them in order. This time we have 3 denominators. So we have to find something that 3, 4, and 8 can all go into. We'll start with the higher denominator, 8, and we ask, can 4 go into 8? Yes, but 3 can't fit into 8, so we're going to have to try another number. Going back to 8, we're going to go through its multiples until we find something that both 4 and 3 can go into. 8 times 2 is 16. 4 can go into 16, but 3 can't. So we go back to 8 and continue. 8 times 3 is 24. 4 can go into 24, and 3 can go into 24. So 24 is the least common denominator. 8 times 3 is 24, so that means we have to multiply 3 times 3 to get numerator 9. 4 times 6 is 24. 1 times 6 is 6. 3 times 8 is 24. 2 times 8 is 16. Now to put the fractions in order, we're going to use the like fractions. Since 6/24 is the lowest, that means 1/4 is the least. 9/24 would be next, so 3/8 is second, and that leaves 2/3 as our greatest valued fraction. To change mixed numbers into improper fractions, you simply multiply the denominator times the whole number. 5 times 1 is 5. Then you add the numerator. 5 plus 3 is 8. And the denominator stays the same. For number 9, multiply 7 times 3, which is 21. Add 1, that gives us 22. The denominator stays the same. Now to do the opposite, to change the improper fraction into the mixed number, we have to divide. We always divide the denominator into the numerator. So we divide 4 into 21. 4 goes into 21 5 times. 5 times 4 is 20. When we get a remainder, you make a fraction out of it by putting the remainder over the divisor, and we get 5 1/4. Then we have to see if it can be reduced, but since 1/4 can't be reduced, 5 1/4 is the simplest form answer. For number 17, once again we divide the denominator into the numerator. 8 goes into 32 4 times. And since there's no remainder on this one, our answer is a whole number, 4. For 16/6, we divide 6 into 16. 6 goes into 16 2 times, and this time we have a remainder of 4. So again, we make it into a fraction. We put the remainder over the divisor. So we get 2 4/6. But then we have to see if it can be reduced. So can anything go into both 4 and 6? Yes, 2 can go into both 4 and 6, so we have to reduce it. 2 goes into 4 2 times, 2 goes into 6 3 times. When you reduce a mixed number, don't forget to bring the whole number over before you reduce the fraction so you don't forget it. When we're adding and subtracting fractions with like denominators, we don't have to go through that least common denominator step that we'll have to do in the next chapter. For a problem like number 2, we're trying to take 3/5 from 2, which we can't, so we're going to have to borrow. We borrow from the 2 becomes 1. The 1 that we borrowed, we change into 5/5 since the denominator's 5. When you're borrowing a whole, you always want to make it into a fraction that matches the denominator of the other fraction. 5/5 minus 3/5 is 2/5. 1 minus nothing is 1. And then you ask, is it improper? No. Can it be reduced? No. So our answer is 1 2/5. For a problem like number 5, we subtract 7/12 minus 5/12. Since the denominators are the same, we simply have to subtract numerators. 8 minus 3 is 5, so we have 5 2/12. Then we ask, is it improper? No. But can it be reduced? Yes. 2 can go into both 2 and 12. 2 goes into 2 once, 2 goes into 12 6 times, so 5 1/6 is our reduced simplest form answer. When you have a problem like number 8, the directions ask you to evaluate the expression x plus 9/20 when x is 11/20. So we'll put 11/20 in the place of x, and we'll add that to 9/20. 11/20 plus 9/20 is 20/20. Is it improper? Yes. 20 goes into 20 once. Answer would be 1 whole. In lesson 9, we're multiplying fractions times whole numbers, except we can't leave a whole number in the form of a whole number to multiply it times a fraction. We have to change the whole number into a fraction, and all you have to do is put the whole number over 1 to make it into a fraction. Here we have 8 times 1/9. We're also going to see if we can cancel. Canceling is reducing before you multiply. So you have to see if there's anything that can reduce with the 8. Since nothing can go into both 8 and 1 or 8 and 9 evenly, nothing will cancel there. This numerator is a 1. Nothing cancels with a 1. So you multiply. 8 times 1 is 8. 1 times 9 is 9. Is the answer improper? No. Can it be reduced? No. Number 4, we have to change 7 into a fraction. Put 7 over 1 times 4/9. Then we ask, can anything go into 7 and 9? I'm sorry, 7 and 1? No. Can anything go into both 7 and 9? No. Can anything go into 4 and 9? No. Can anything go into 4 and 1? No. Then you just multiply. 7 times 4 is 28. 9 times 1 is 9. Is the answer improper? Yes, so we need to fix it. We need to divide 9 into 28, which goes 3 times, with the remainder of 1/9. And can that be reduced? No. So our answer is 3 1/9. For number 7, we'll change the 8 into a fraction, 8 over 1 times 3/4. Now we'll see if we can cancel. Can anything go into 8 and 1? No. Can anything go into 8 and 4? Yes. What can go into 4 that can also go into 8? That would be 1. That would be 4. 4 goes into 4 once, 4 goes into 8 twice. Now when we try to cancel something with 3, the only denominators we have are 1s, and 1s don't cancel with anything. So we multiply 2 times 3 is 6, 1 times 1 is 1. Is it improper? Yes. So our answer is 6. When we have a problem like number 9, our expression is 12x, which means 12 times x, and x is 2/3. So we have to multiply 12, make it into a fraction, times 2/3. Can anything go into 12 and 1? No. Can anything go into 12 and 3? Yes. What can go into 3 that can also go into 12? That would be 3. 3 goes into 3 once, 3 goes into 12 4 times. When we try to cancel the 2, the only denominators left are 1s, and 1s can't reduce with anything. So we multiply and get 8 over 1, which is improper, so our answer is 8. For a problem like number 15, we change the 6 into a fraction, and we're multiplying it times 1/8. Can anything go into 6 and 1? No. 6 and 8? Yes. 2 can go into both 6 and 8. 2 goes into 6 3 times, 2 goes into 8 4 times. Nothing's going to cancel with this numerator 1, so all we have to do is multiply. Is the answer improper? No. Can it be reduced? No, so that's our final answer.